2050, and then we are writing B, and we are committing it. So B becomes 2050, and again control goes to T2 where we are reading B, and it is B plus temp, and temp we already found it to be 10% of A, that is 95. So 2050 plus 95 we get, so 2145, and that's also B will be 2145.
And A is going to be 855, right? A was.
Yeah, 855.
So what do you conclude here, Pavitra?
The sum 855 plus 2145, it is 3000. So the sum is same, like initially also the sum was 3000, finally also the sum is 3000. So no problem.
So concurrent execution of the transactions can proceed without any issues, right? Here in this case.
In this case, concurrent has no problem.
Right. So can you have a look into this schedule 4, figure 14.5, schedule 4? Again, we are going to have concurrent execution of the transaction. So the processor time is, you have your CPU time allotted to your transaction for a short time. There is a context switch, then a context switch occurs, and the CPU time is given to transaction T2, followed by T1, and then T2. So what happens in this case, Pavitra?
Yes, so first when T1 is executed, A becomes 950, but then we are not writing the value of A. So when the control goes to T2, again when it's reading A, it will read A as 1000 only because we have not written A. And then the 10% of A will be 100, and now A becomes A minus temp, so 900, and then we are writing A. So now the value of A is 900, and then we are reading B, but then that's all, the control gets switched on to T1. Now we are again we are reading B. So B first time we are reading, so it will be 2000, and then B plus 50 will get 2050, and then we are writing B. Now when the control goes to T2, B is equal to B plus temp, so 2050 plus temp was 100, so 2150. So B finally is 2150 and A was 900. So the sum is not 3000. So because of concurrent, we have an issue here. We get an inconsistent state.
So here the value of A is going to be 950.
Yes, but then that we are not writing A, so like initially we are having A is A minus 50, which is 950.
Yeah, that's it. Initially you are not writing it. Later you are going to override the value of A as 950. Right?
Okay.
So initially A was $1,000, 1000 minus 50, 950, but you are not going to write it onto the variable A. You perform a context switch. You are going to find 10% of A, which is going to be 100.
90. 100.
100, right? So A equal to A minus 10, so it's going to be 900. So the initial value of A is going to be the value of the A that is being updated. Initially it is going to be 900. It performs read of B operation, then there is a context switch. The write of A operation occurs. So write of A operation occurs. Here the value of A is updated as 950, right? And you are going to read the value of B in transaction T1. So T1 B plus 50, it's going to be 2050. And then again you are going to perform context switch. Temp value is going to be 100. So 2150, right? So the new value of sorry
B is 250.
right here B is equal to, sorry, here it's going to be 2050. Here you are going to write it, followed by it's going to read the value of it's going to add the value of B, B plus temp is going to be 100. B value is going to be now 2050, right? 2050 plus 100, 2150. I think it's going to be I think right of B 2000 plus so A value is 950, correct? B value should be 2050, whereas here it's going to be 2100. D plus so 2100 plus 950, it works out to 3050. So money is created during the process transaction. Since the sum of accounts A and B are not preserved during the execution of this transaction, we say that there exist some conflicts if the transactions are executed parallelly. So the conclusion is that if the concurrent execution of the transaction is left entirely to the operating system, it may result in the database in an inconsistent state. So hence it's the job of the database to ensure that any schedule that is executed will leave the database in a consistent state. So we have a concurrency control manager component of the database that carries out this task. Right. So this is what we concluded in the last class.